The Transmission Control Protocol, known as TCP, is used to move data between hosts which are connected to IP networks. TCP makes no differentiation between hosts which are sitting several feet apart or hosts that are thousands of miles apart. TCP makes guarantees about the data arriving at the remote host and arriving correctly. In those instances that data packets must be split into pieces and sent across an unreliable packet network, TCP guarantees no data corruption and data will arrive and be reassembled in the correct order. In order to guarantee delivery, TCP uses many things such as sequence numbers, checksums, and timeouts to ensure the data is delivered across the network correctly. To explain the very basic process of the Transfer Control Protocol, it would look something like this. Each packet of sent data, once received by the destination, has an acknowledgement sent back to the source. This method of transfer can be quite slow, especially if that packet has to traverse a satellite. Each time the data packet is sent via satellite, it takes 4 seconds each way to go from the local host up to the satellite and back down to Earth to the remote host. So in total, it would take 8 seconds just to send 1,000 bytes of data to the remote host and have an acknowledgement that the packet is received. One way to improve the transfer rate is to have more data in transit by sending more data at the same time. To speed up TCP's guaranteed deliver process, a mechanism called sliding windows was created to ensure that the maximum amount of data is always in transit within the data network. Let's say our transmission window size is 3K and each data packet is 1K. So the window can hold 3 packets, enable, and the first 3 hunks of the file can be sent at the same time, but in sequence. Once the first packet is received, an acknowledgement is sent. The window then slides to the right to incorporate the 4th packet, which then is sent. Packet 2 is received and acknowledged, and packet 5 is then sent, and on and on. TCP ports is a mechanism within TCP that enables it to keep track of what application is being used on the source and remote computers. For example, on the same computer, the file transfer protocol and the remote login processes will use TCP. TCP, in turn, needs a way to send the file to the file transfer process and the login data to the remote login process. The way that TCP keeps data flowing between applications correctly is to use ports. On the source and remote machine, TCP assigns a number to uniquely identify the application to which the data should be sent. This number is called the preassigned port number. So if you want to connect to Telnet, fill in the destination port number 23. As a contrast to TCP, the User Datagram Protocol, or UDP, is a transport layer protocol responsible for end-to-end data transfer, but it does not guarantee any reliability. It is a very simple and fast protocol. For example, compare the UDP header to the TCP header. The UDP header is 8 bytes in size, in comparison to the much larger TCP header of 24 bytes. The source port, destination port, and length are required. The checksum is optional. If it's set to 0, then there's no checksum. Otherwise, there's a checksum present. The reason the User Datagram Protocol is chosen over using TCP and its reliability guarantee is that TCP imposes a heavy overhead. For example, for each TCP packet, it computes a checksum, has to keep track of sequence numbers, figures out if something was dropped, prioritizes packets using urgent pointers, enables special options. UDP doesn't do any of that. It just fires packets. As they travel through a network, data packets use lines of varying speeds, routers, CSU, DSUs, and modems, and different routing protocols. 3 of the different routing protocols in use are the Routing Information Protocol, or RIP, the Open Shortest Path First Protocol, or OSPF, and the Border Gateway Protocol, or BGP. Finally, when comparing TCP and UDP, we find TCP is slower, but arrival is guaranteed, whereas UDP is faster, but delivery is not guaranteed.